Welcome to Kenton Teaches. Enjoy the video.
You start by preparing the environment and data. Create a virtualenv, install OpenCV, dlib, and the face recognition library so you can access reliable embeddings. Once done, collect and label 5 to 20 clear images per subject in a consistent folder structure. This improves accuracy. Next, write a minimal camera capture script to confirm OpenCV reads frames at 640 by 480 and roughly 30 FPS. Make sure the feed is stable before adding detection so you avoid later timing issues. You now convert images into numeric representations, detect faces in each training image, and compute 128-dimensional embeddings. Once you have embeddings, store them with labels in a serialized file like NPY or PKL so loading is fast in production. Then implement a matching step. Use a KD tree or scikit-learn K-neighbors classifier to find the nearest embeddings in live frames, applying a distance threshold such as 0. 6 to decide recognized versus unknown. This pipeline reduces runtime work and improves You finish by integrating detection, embedding, and matching into the live processing loop. Capture frames, optionally resize to 1/2, detect faces, compute embeddings in batches, then match and annotate frames with boxes and labels. Once done, profile and optimize, skip frames, reuse alignments, and offload heavy work to a GPU if available. If recognition is poor, troubleshoot one key item, data quality, improve lighting, add more varied images per person, and adjust the embedding distance threshold to reduce false accepts.
Thanks for watching. Please subscribe if this video was helpful.